Okay, several questions. I'll give you at least a little blurb right now, and then when necessary, we'll go into a little more detail on a separate board. How do you solve for power function? Well, this occurs when you have like two equations to get the two parameters, right? So you get like, you get like y equals ax to the p. You get two equations, right? So you eliminate a from the two equations, right? And you get to an equation that says something like 4 to the p equals 7. Okay? So using, the things that you know how to do, or I've seen you do with two simultaneous equations, you can get down to this. Okay? Now, if you had an exponential model, that would be like y equals a b to the x, right? So you get two equations and so forth, and you would eventually get down to a solution for b, okay? And it would be like b to the 17/43 equals 9, okay? Now, one of these you can solve very easily, just using the laws of exponents, and the other, you got to use logs. And of course, most people haven't had logs, okay? But right here's a rule that we can use to solve for the log, okay? And it's just something you can punch into your calculator. So, for this model or this model, you can always get down to this equation, or an equation very much like this, or an equation like this, right? Okay? So which one can you solve easily without logs?
Exponential.
This one. And what do you do to solve it? Raise both sides to the 43/17, right? Mm-hmm. Because and when you multiply the powers, which is what you do when you raise a power to a power, everybody should be completely familiar with that if you've had algebra, okay? You get that in Algebra 1, okay? You might not use it in this context in Algebra 1, so you might have to hustle a little bit, but you have to know the laws of exponents and be comfortable with them. If you aren't, practice it, okay? Go to laws of exponents, look at Khan Academy, look at anything, practice, do many problems that involve laws of exponents, okay? I find people are just handcuffed when they come into many of my courses because they're not aware of the laws of exponents because they do algebra by superstition rather than by rules. If it looks like this, you do this. Why do you do this? Because if it looks like this, you do this. That's the way people learn to do algebra. And it's a good way to do algebra quickly, but if you don't know why, if it looks like this, you do this, you're going to make mistakes. And it's going to cost you more time than it takes you to get used to the laws of exponents. So please do that. Anyhow, end of lecture on that. But this is very easy if you know the laws of exponents, and you've done a few of them. And hopefully you've done a few of them. Okay? Now this one I've just kind of left off. Said here's how you do it. If you know about logs, you can do it. Here's the rule. I gave you the rule, but not everybody. I don't expect everybody to just, I give you the rule and say that's what you do. I did demonstrate a problem, but just one thing in the booming, buzzing confusion of the first few days, right? So I don't expect that everybody would have done that. Although if you get into a course in a challenging institution, you would be expected to review your notes and do that, right? At this point, I don't expect everybody to have done that, okay? Because it's new and it's unfamiliar. Okay, well, anyhow, you got 4 to the p equals 7. So that means P equals log to the base 4 of 7. Now, how are you going to put that into your calculator? You got a log key, right?
Yeah, but that's common log.
It doesn't matter whether you use the common log or the natural log, as long as you use the same one for both. Okay? So I could say or natural log of 7 would be fine. Natural log of 7, well, no, never mind. Not there yet, we got to use this, right? Okay, what's log base 4 of 7?
That would be
Well, this says what log base b of x is, right?
log of 7 over log of 4.
Yeah, b is 4, and x is 7. So this is log of 7 divided by the log of 4. That's how you relate different logs.
Okay.
And I could say that's or very easy to prove that if this works, then this works.
Yeah.
Okay? A natural log is log to the base e, and we haven't talked that much about e, but we will. Okay? Make sense?
Yeah.
That's how you solve it. And then,
Is it possible to put two different numbers into that function and get the same overall result? In other words, can 3x plus 5 equal 3x plus
b to the p equals c is the same as saying that p equals log to the base
Instead
b
of calling it x, we call it a plus
of
b.
c.
Alright? Do a little bit.
And the reason for this is simply because if you do your exponential graph
That line equals that line,
and then graph the inverse function,
which says
you switch coordinates. And this is just what happens when you reverse the x and y coordinates.
but with x squared.
It follows in a very simple manner that I don't necessarily expect you to discover, but you could, if you think about it a little bit. Most of you, I think, could. Okay?
Squared.
So, well, it's not a pre-calculus class, but some of you have had pre-calculus and haven't seen this. And if you've had pre-calculus and haven't seen this, you didn't have a complete pre-calculus course. Okay? And if you didn't have a complete pre-calculus course, it's probably not the fault of whoever taught you that course. It's probably the fault of a school system that wants to put everybody and their brother into a pre-calculus course, whether they're ready for it or not. And maybe our fault for accepting the results of the placement test, which really don't do a good job. And probably, if you took it as a dual enrollment course, you're in a high school environment, you're not used to working to college standards. You are, but most of the students in your class aren't. So we're working on that. So if you didn't get a complete pre-calculus course, well, go complete it. Go to Khan Academy. You know everything. You got really great algebra skills. You got really great thinking skills. I see it. Okay? So you can do it, but you really want to. And you probably should before you go into a calculus course. And also master everything that we're doing this week, because it'll give you a context for your calculus course. Okay? And I will probably also do a couple of videos just on high points and tell you, if you're going through a calculus course, when you get to this point, here's how it relates to what we did in governor school. Okay? When you get to this point in calculus, think about this. That's all we're doing. Because you lose the forest for the trees when you're in a calculus course. The other thing I would say is do way more problems and way harder problems than you're probably going to have assigned to you. Okay? Just good advice, and put more time in it than you think you need to. Okay. It's foundational. Okay, well, a lot of side comments, but there's a couple of questions, okay?